Hello, my name is Mama Aziz bin Khairul. For today, me and my team member will be presenting about our project on ECG 563, which is road safety audit. We will be conducting our project at UITM Shah Alam. So, for road safety issues, by synthesizing various engineering fields, our group analysed the safety concern at the UITM Shah Alam, Jalan Ilmu 1/1 and Jalan Cendekiawan 1/15 junction. We combine basic road design theories with expert perspective on human behavior and traffic management, validating this through on-site inspection. Following JKR and standard and global benchmark, we pinpoint several critical hazards, such as obscure signage that leave motorized uniform and dangerous high-speed turns that elevate accident rates. Furthermore, the absence of signalization leads to rapid maneuvers, increasing the likelihood of rear-end or side sweep crashes.
Next, I will continue with the methodology of the experiment. To address the identified safety concerns, we are selected experiments and tools grounded in traffic engineering knowledge and practical field method. For this study, we conducted traffic data collection over 2 separate days and focused on 3 specific time frames, which were 7 a.m. until 8 a.m., 5 p.m. until 6 p.m., and 6 p.m. until 7 p.m., representing morning peak, evening peak, and night condition. A radar speed gun was used to measure vehicle speeds, position 30 meters upstream from the junction to capture free flow speed under normal condition. All the apparatus and tools were operated according to the standard procedures, and although minor limitations arose due to environmental constraints such as lighting and weather, the majority of the data collection follow proper methodology. Our tool selection was based on established engineering practices and supporting literature, and the resulting data was deemed reliable for further analysis and drawing valid conclusions.
For this study, we conduct a traffic data collection over 2 separate days, focusing on 3 specific time frame: 7 to 8 a.m. morning peak, and 5 to 6 p.m. evening peak, and 6 to 7 night condition. And for the morning peak, we get the average speed of 23.9 kilometer per hour. Evening peak, we get the average speed 25.56 km per hour, and night peak average speed of 25.929 km per hour. So the total of speed limit average is 25 km per hour.
We have chosen a T-junction road at the Bukit Tonggak. Without a traffic signal, the crossroad becomes a place of high confusion, with vehicles from all directions competing for right of way, increasing the probability of rear end and angle crashes. Each lane will measure using a proper measuring wheel and to meet a JKR geometric design standard, to ensure that its safety of a road using proper material. This is to ensure the safety and efficient of traffic flow. We observe there is no zebra crossing line to cross the road. So we decide that we need to create a zebra crossing line on the road to ensure the safety of walk pedestrian to cross the road. The zebra crossing line should be placed a few meters from the intersection point. This allows the safety of pedestrian to walk through the road using the zebra crossing line using the GKR standard. This is following a minimum setback of 5 meters from the corner. We observe there is a speed limit at the junction, and there is also a sign of slope that to slow down the vehicle along the junction. There is also a warning sign of a slippery road to ensure the safety of the vehicle that use on the junction, so that it is good for warning vehicle using the road. For this study, we conduct traffic data collection for over 2 separate days, focusing on 3 specific times: 7 to 8 a.m. morning peak, 5 to 6 p.m. evening peak, and 6 to 7 night condition. A radar speed gun was used to measure vehicle speed, position 30 meters upstream for the junction. For traffic volume and classification, we use a manual tally counter to record the number and the type of the vehicle at 15-minute intervals. This allows us to observe traffic flow fluctuation and analyze speed sub-internals. Our data collection follow proper methodology, making the result reliable for analysis.
So next we will go to the mitigation part. So based on field observation and speed data collected at the junction of Jalan Ilmu 1/1 and Jalan Cendekia 1/15, several mitigation measures are proposed in accordance with JKR Arahan Teknik Jalan to improve road safety. So first we'll go to the speeding. Although the speed limit is 25 kilometers per hour, observed evening and night speeds slightly exceeded this value. Speed calming measures such as rumble strips and repeated speed limit signage are recommended to reduce approach speeds. Next is the alignment. The road alignment allows high-speed turning movements. Chevron signs and clearer edge lines are proposed to improve driver guidance and reduce loss of control risk. Next is the cross-section. The lack of clear road edge definition may encourage faster driving. Painted shoulders and edge markings are recommended to improve lane discipline and speed perception. Next, geometry layout. The existing junction geometry allows smooth and fast turns. Reducing corner ready and adding channelization markings will help lower turning speeds and reduce conflict severity. Next is the traffic control. The junction currently operates without priority control, so installing stop or giveaway signs with stop lines is recommended to regulate vehicle movements and reduce collision risk. Next is the visual aid. So some traffic signs are obscured and road markings are faded. So improving signage visibility and repainting markings will enhance driver awareness, especially at night. So next, we'll go to the next part. Vulnerable road users. So as this is a campus environment, pedestrian activity is high. Marked pedestrian crossings and warning signs are proposed to improve pedestrian safety. Next, roadside safety. Fixed roadside objects near the junction increase injury severity. So removing or shielding these obstacles will create a more forgiving roadside environment. Next, we go to street lighting. So limited nighttime visibility was observed. Improving street lighting at the junction will enhance driver perception and reaction time. Next is landscaping. So vegetation near the junction restricts sight distance. So regular trimming is recommended to maintain clear visibility in line with JKR requirements. So lastly, we will go to the road surface. So worn pavement and faded markings reduce skid resistance. So resurfacing and repainting road markings are recommended to improve braking and guidance. So overall, this mitigation measures collectively improve speed control, visibility, and junction safety, contributing to a safer road environment within the UiTM campus.
Okay, now we move to the conclusion. The safety study at the Jalan Ilmu 1/1 and Jalan Sendekawan 1/15 in UiTM Shah Alam has been identified the many issues. From the site visit, the busy spot has a big risk for its soul and vehicle. A main obstacle is the lack of basic signage, making the path is tough to use. Speed is the big concern for this safety audit. We can see the vehicle moving so fast when the lanes lack of empty. Since no bump exists to slow them down, this has made accident likely. Additionally, the spot lack painted walk path. This is so unsafe for the user as people have no safe zone to walk. To fix this, we suggest to adding the bike side signs to guide each user. Speed bumps or caution signs should also exist to make the people slow the vehicles down. Lastly, adding a white wolf path is vital to give a safe zone to the user. For the final, fixing signs, slowing down the vehicles and adding the walk path will help. This simple change will make the junctions much safer for all the student and the user for this. That's all for the conclusion. Thank you.